you're implementing AI inside of your company, one common problem that you're going to see is AI data readiness. And actually, in a McKinsey report, this is one of the most cited problems. Here, they say that more than two-thirds of high-performing companies say data is the primary obstacle for enabling AI. And according to them, this is one of the key reasons why only 7% of companies have a full scale out. Now, I've built AI systems for some of the world's largest companies, and every single project requires some data manipulation before you can even start working on it. So here, in this video, I'm going to break down how we actually make your raw data AI ready. Now, there's 4 things we're going to go over here. The first one actually starts even before development. This is the scoping phase. The next here is what I would call preparation, but this is more of making sure that we can convert this data into a usable shape. Now, next is how do we actually connect to this data? You may have heard online about MCP and all those pieces, but I would really say the more important piece is the frequency in which we actually connect to this data. Now, lastly here is the context layer of it. You could have all of the data in one uniform place. However, the AI doesn't know what to do with it. What do the headers mean? What do the columns mean? And how does it actually manipulate this data to get the outcomes that you need? So let's start with our first section, which is the scoping aspect of this. Now, there is a use case selection, and that is its own topic, but let's say you've already identified all of your use cases. And let's just say that some of them actually share data sources. There's a lot of overlap here. Now, because we have limited engineering resources, we might as well start on the high priority use cases where we could re-leverage our data pipelines. Now, this actually does a couple of things for you. One, obviously, it's the speed across multiple use cases as you're re-leveraging data pipelines. But 2, it actually does a subtle thing of minimizing the downside risk for one specific use case. See, if you're doing a use case that has a very, very unique data set and it's all on its own in its own island, if that use case messes up and maybe the ROI just wasn't there in what you were expecting, then you burned all of your resources for something that's not really fully re-leveraged. Here, at least if one of these high value use cases, they end up not working out, that's okay because the time to value to the next one is going to be a lot easier to get to. Now, one aspect on scoping is every company is very, very different. For instance, some companies might have a large data lake from a previous digital transformation investment. So you might be able to leverage that, but maybe some of the data isn't there. So you have to wait for migration or something along these lines. Or maybe this is your first AI use case and you just need something quick to have a quick win inside the company. Then you might just not even build a full pipeline and just get a simple extract going. Now, each company has its own unique circumstances, and we obviously can't cover all of that in this video. But a good rule of thumb here is to favor AI use cases where you could reuse some of those data foundations. Now, this is more of a strategic lens. Now let's go into something a little bit more tactical, which is the data preparation side. Now, there's a few aspects to what I'm calling data preparation here. The first one is essentially how we're looking at the landscape and how we're going to model the data effectively. Let's first look at structured data. Now, one of the big things here is actually identifying which data sources and mappings are actually required for our application and for our use case. And this is what we call data modeling, and you may have seen an ERD before. And this is important when we look at multiple data sources or multiple different tables within a data set, because then we can see how everything is relating to each other. So when we go and build out this use case, we're going to want to get different data extracts. We don't want to build pipelines just yet right now. Then we map which fields are relevant to one another. First, we want to trim what's actually relevant for our AI use case. Now we look at how the different data sources connect. We're looking for things like keys, primary keys, and how could we join them and what the associations are between them. And doing this process actually matters for a couple of different reasons. One is fragmentation. As we know, in large companies, there are data silos essentially everywhere. And so when the data is scattered, the AI only really is able to partially reason across the data instead of the whole complete data set. And this sort of model does make it easier to stitch this viewpoint together. Second is we can actually resolve duplicates and any conflicts inside the data as well. Here, some data sources will actually hold the same thing, or maybe they need to be joined in some sort of way. Now, once we've modeled and we understand what's in place, then we can actually start building data pipelines for the structured data. But now let's move on to unstructured data. Now this one's actually a bit straightforward. You may have heard of the term RAG, and this is the typical approach for looking at unstructured documents. But the biggest thing for unstructured data is just identifying what are the documents that you realistically need. See, you want to weed out duplicates, you want to weed out old versions, because the AI is going to get confused if it's a 2021 version versus a 2022 version with the exact same information in slightly different wording. There's another added piece here, which is adding file level metadata or folder level metadata as well. As an example, I was building a use case for a very large Fortune 500 company, and they had these PowerPoints with no realistic naming convention or anything along those lines. Now, the front page of all these PowerPoints actually had some very important information that we would have needed to query, at least on the large scale. Now, what we did here is we actually built a parser to then extract and create metadata around these unstructured documents. Then from there, whenever somebody asks about this specific author, maybe the name, maybe the type of statistics in particular, then it'll be easier for the AI to actually query that information. Now, in typical unstructured data fashion, I mentioned RAG, so we chunked, we index it, and then we put it into a vector store. Now, one thing for this use case is we're actually able to link the unstructured data with the structured data. And so this makes it easier for the AI to actually bridge the gap between structured and unstructured data. So if you ask about a specific experiment, it could look at the structured data and pull out the relevant table and information, as well as through the table, link the unstructured documents as well. Now, the second part of data preparation is actually going to be data cleaning here. So now that we've modeled the structured data and we've curated the unstructured data, there's going to be real data quality issues that are going to show up regardless. But they do look different depending on your data type. And we're going to go through some of this here. Now, for structured data, there's some common issues. There could be missing values, for instance. There could be inconsistent formats. For instance, one database could have California, another database could just have CA. Maybe some of the values when you're linking them could be inaccurate. Or maybe there's even just some broken relationships across your data model that you're going to have to fix. Now, for the unstructured data, there's also some additional common issues here, which I did mention before. First is duplicate in older versions. The AI is going to get confused if it's a 22 versus 23, and that very, very specific nuance might be harder to actually retrieve. There could be some conflicting information. Maybe one document says one thing versus another, and the AI has to reconcile that. I would say one additional big one here is actually a bad extraction when you're doing your RAG pipeline. As an example, let's just say there's going to be some tables or there's going to be some images that you're going to have to parse inside of your document. Here, there's going to be some different ways you could do verbalization, at least for the images, and there's some specific ways of doing it, but just making sure these pipelines are stable and they're accurate across the whole piece is going to be very, very important. Lastly, across both of them, no matter what, you're going to have to worry about PII or any sensitive information. So this is just removing social security numbers, maybe there's some specific names involved. And this is actually more related to compliance rather than anything else. Now, data cleaning, this actually is going to be a very large topic in general, but these are probably the biggest ones that you'll see for both types of data sources. Now, one important thing to keep in mind here is what is the information that the AI should be able to access versus not be able to access. And this will have to affect the way that you do your data modeling or what's going to be put in your unstructured database here. Now, the next thing we need to do is actually just connect our AI to the data sources here. Now, this could be something as simple as just an access token where the AI could access it, or it's going to be as difficult as actually pulling the data into a separate environment so that AI can then access it. Now, there's two things that we need to look at here. One is just role access in general. There's some security risks with the AI just directly connecting to a database and making sure there's some security mechanisms around it. But the second is, what is the frequency in which we want to pull that data? How often does it need to actually get this information? Now, on the security side, this is a little bit more nuanced and is actually dependent heavily on the actual use case itself. For instance, maybe it can only access to one table, or maybe there's only a couple of columns inside that table. Maybe there's a row level access you need to provide it. So what I want to spend this time more on is actually how we realistically connect to the data and then what the frequency actually needs to be to pull it. There's only really a couple of ways to actually connect to data sources. First is any API and connectors. So most cloud tools have some pre-built connector around it. And this is actually the easiest way to move data from one place to another. And when you actually hear MCP, I would say a lot of it is more of just wrapping around and having the AI call an API, for instance, or one of these connectors under the hood. Next is ETL or ELT pipelines. This is extract, transform, load, or extract, load, transform. And here you extract it from the source, you transform it in any way consistent format that you would like to have, and then you load it into this new database that you might need. Now, another way is change data capture. This is CDC, and this only moves what is changed. It's just gonna be a new row or an updated field or something along those lines, and it's only gonna move those changes. And lastly is like a real-time streaming. This is event level streaming. So something like Kafka or Kinesis or something along these lines, this will give you near real-time streaming. But I would say the biggest thing is understanding what the frequency in which you need to have this data for your specific use case. Most common one here is just pulling the data in batches. So you could schedule it for every single week or every single month and have a large data pool for the past month, for instance. Now for near real time, this is where that CDC pipeline actually comes in. See, instead of moving everything in from the database, we're only changing the differences here, and so it keeps it actually pretty current. And lastly, that real-time or streaming that we talked about at the end of there, this is continuous, and you want to use this that's very specific for your use case. See, the biggest thing that we need to get around is actually the costs in which it is to implement each one of these. See, real-time is the most expensive and the most complex, and that is because it needs infrastructure running 24/7 for the real time. And so a batch job using an ETL approach, this is only going to run maybe once a month or once a week. And so here for your specific use cases, it actually comes down to more of a cost approach of what is the frequency in which we need to pull this data from. Now, let's look at the last part here, which is the context aspect. Now, let's say that we've done everything that I talked about in the last couple of steps, and we're able to access all of the data and pull the data in. The last thing we need to figure out is how the AI is going to understand the data here. And I'll actually give you an example from my recent use cases. We just had columns that were full acronyms, and there were multiple columns that were just full acronyms across the whole data model. And the AI isn't going to know what that means. So here you need to have some sort of explanation to the AI so that it understands what those columns mean. Now, it's not just that, there's also going to be a row level information as well. Here's an example of customer type. You could have a customer type of 1, 2, and 3. The AI has no idea what 1, 2, and 3 means in this context. Now here, this is the context layer of actually having the AI understand what each one of these pieces mean. You may have heard semantic layer or knowledge layer. This all basically means the same thing, at least at this point. Now, there's a lot of information that could go into this layer, but I'm just going to give you some examples here. I'll say the most common one is a business glossary or some sort of dictionary. This could be what those codes are, what those tables mean, or along those lines. Another one could be any sort of tribal knowledge or institutional knowledge that the end users just know about it. There's also metrics definitions, for instance, active customers versus non-active customers. What does that specifically mean? And so the AI can understand that. And so here, the good thing about this is once you define the meaning once, it actually helps you essentially everywhere. So if you use the definition of active customer for structured retrieval, it will also help you with the unstructured retrieval as well. Now, one last thing I want to touch on here is just security in general, right? Being able to access, specific information on the data model level, or maybe some information at least on the context layer. All of these things also need to be added onto your security protocol as well here. Now here, this is sort of the overarching pieces that are required for data readiness, right? We have understood based off of the scopes of what data we actually need at a high level. Then we start mapping it and identifying what is needed, at least on the individual project level, at least for that specific use case. Then we start looking at columns, we start looking at headers, we start looking at rows to make sure that we are pulling in the right information, and we are doing data cleaning exercises there. And then lastly, not really related data, but more on the context level, what is required to make sure that the AI can actually traverse it effectively. So if you have any questions, please just let me know in the description below. Thank you so much, and I'll see you in the next one.